Welcome to Zomiga Videos. In this video, you will see how you can quickly and easily design and build multi-tier data-centric .NET applications using model-driven development and code generation powered by our unique Zomiga technology. So what are the benefits of the model-driven development as compared to the more traditional software development? First, it can significantly reduce the time to market for your product, allowing you to quickly build the initial prototype and then iteratively validate it and refine it with simple model updates. Along with that, it can boost developer productivity and drive down the development costs. Zomiga solution templates, pre-configured for your selected architecture, will get you set up for the architecture best practices in no time. Code generation across all application layers will save you countless hours of writing plumbing and boilerplate code while still allowing to customize and extend the generated code. And these savings will be magnified many times over if you're developing large-scale data-centric applications. The pre-configured project structure and the generated code will ensure a clean, consistent, and robust design for your application. Layered multi-tier architecture will allow you to swap or reuse application layers. The generated code follows the best software development practices, including separation of concerns, MVC and MVVM design patterns, and dependency injection, which allows you to plug in your custom implementation of various classes. All this in turn can reduce the maintenance costs, especially given that you can update the model and then regenerate all application artifacts from the new model without losing your customizations. The detailed design documents for domain and service models or the static data, which can be generated right from the model at any time, will not only reduce development and maintenance costs, but can also improve team communication by allowing to easily review those designs for all the project stakeholders. With the model being stored in a plain human-readable XML, you'll be able to version control it, track changes, search any text in it, and use it with distributed teams, all using your favorite tools. Finally, developing a logical, platform-independent model can also future-proof your investment, where you'd be able to generate artifacts for new technologies and frameworks as soon as those become available and supported. With the current pace of technology, for example, a brand new framework that you start a large project with may already become outdated by the time you finish the project. In subsequent videos, you'll see how we can reuse the code for a classic ASP.NET web application that we'll create in the current video in order to develop a desktop WPF application, as well as a modern single-page application while generating them all from the same logical model. Now that you get comfortable with model-driven development, let's have a quick overview of what is Zomiga and what it consists of. Zomiga.NET is a Visual Studio extension for modeling and building .NET applications within Visual Studio. To get you started, it includes a number of solution and project templates for different architectures. Among those is a special project type that lets you organize your model components and helps you edit them in a human-readable XML files with enhanced outlining, IntelliSense support, model validations, and navigation of the model entities. In addition to the model files, the model project contains a large number of configurable generators that help you run model transformations and generate various artifacts for all application layers. The generated code is very clean and straightforward, as it uses our state-of-the-art open-source C# or JavaScript frameworks, which provide all the glue and the features that make up the application. Finally, Zomiga contains a set of document templates, which allows generating detailed design documents right from the model. Now that you have a better idea of what is Zomiga, here's what you'll see after you watch this entire video. In a nutshell, we'll take a sample SQL Server database, AdventureWorks from Microsoft, which represents an enterprise information system for a hypothetical mid-sized company, and will create a powerful, full-featured web application for one of its modules. First, we'll start with the Zomiga solution template for the web application, and then import the model from the structure of our sample database. Then, we will generate quick and basic views for the sales module, and we'll review what we've got out of the box. Next, we will start iteratively modeling and building the search view for searching and browsing of the sales orders. You'll be able to learn a number of simple techniques for building applications with Zomiga and appreciate the ease and the speed of development it provides. After that, we'll move on to iteratively modeling and building the details view for editing existing sales orders or adding new ones. This is where we'll leverage the techniques we learned before and also learn some new, more advanced techniques. On top of it, we'll add modern claims-based security to our application, both to authenticate the user and to secure any features that require authorization. If you worry about missing any details in this video, you can relax now. The complete walkthrough for this process is available on our website, and the final code for the application is also shared online on GitHub. We'll start off by launching Visual Studio and creating a new project in it. Once you install the Zomega.net Visual Studio extension, you will see a number of Zomega solution and project templates in the New Project dialog. For the current application, I'm going to pick the ASP.NET Web Solution template based on the classic web forms framework that is familiar to millions of developers. This solution will have one of the simplest multi-tier architectures, which makes it easier to demo. Even though it's based on the classic ASP.NET framework, it will nevertheless use one of the best modern design practices under the hood, such as separation of concerns, MVVM, dependency injection, OWIN, and so on. In other words, everything that its alternative ASP.NET MVC was designed to address. If you prefer to use a more modern web architecture for a single-page application, then you can pick a different solution template and use steps similar to what we show in this video. We'll also show you how to convert the current application to a SPA in a separate video. I'm going to enter the solution name and hit OK. This will create and configure all the projects for our solution and install the NuGet packages that our solution depends upon. The structure of our solution is pretty simple. Right in the middle you can see the model project, which will have our Zomega model and the generators. Under the model project we have two projects for the service layer, one for service and data contracts, as well as other classes that can be shared between the presentation and service layers, and another one with the actual service implementations, using the entity framework. Up above, we have two projects for the presentation layer, one for the presentation logic that is UI agnostic and can be reused with other types of clients such as WPF, and another one with the actual ASP.NET views. With the current architecture, both presentation and service layers will be running on the single tier, the web server. But our separation of the layers also allows running them on different tiers in a more distributed architecture. Now that we have set up our solution, let's import our Zomega domain model from our database. I need to find the import from database generator in the model project under the model enhancement folder and double-click it to open its properties. Here I will specify the database connection for the generator in a separate connection dialog, and we'll save it as the default project configuration so that other generators could also use it. By default, the generator is configured to output database objects as individual model files, grouped by module under the import folder. Let's run the generator and make sure the database objects were properly imported into the model. We would like to build out the sales module in our application, which would allow browsing and entering sales orders in the system. These objects are stored in the sales order header database table, so let's open the corresponding file. To better see the object it contains, let's collapse it to definitions. As you can see, sales orders consist of the header object and two sub-objects, for a list of line item details and a list of sales reasons. Before we add the standard CRUD operations, along with the search and details views, first we want to give these objects better names, since they will be used to name the corresponding views and data objects. This will save us from renaming those later. I will remove the header from the primary object's name and will shorten the names of the sub-objects, since they are automatically qualified with the parent object's name in Zomega. Now let's go ahead and add the standard CRUD operations and views to this object by running the full CRUD with views generators on this file. Let's collapse to definitions again and review the model elements that we have added. As you see on the screen, the generator added standard CRUD operations to both the object and its sub-objects, as well as a special readList operation, which returns a list of objects based on the specified criteria. Additionally, it defined a number of presentation layer data objects that are based on the structure of these operations and serve as view models for the UI views. Finally, it added standard search and details views and also configured and linked up all these model elements to get you all set up right off the bat. Now let's build the model project to run all the generators that are configured to be included in the model build. You can actually see all the generators being run in the output window. The generated code should work even without any additional changes. So let's go ahead and hit F5 to build and run our application to see what we've got out of the box. The application opens up at a blank home page and uses classic layout, a header, a footer, and a menu bar that has a sales menu for our module. Let's open the sales order list screen for searching of the sales orders. The screen consists of a collapsible criteria panel, search actions, and the result grid down below. By default, the criteria panel has criteria for all objects fields, and each field has a drop-down next to it with a list of applicable operators. If you enter invalid or missing values and hit search, the invalid fields will be highlighted and have a tooltip with the error message, and the summary of all the validation errors will be displayed under the criteria panel. Let's search for sales orders that were made on January 1st, 2012. Notice how date fields automatically have a calendar control pop up. The criteria panel gets collapsed and the list gets populated with the search results. Again, by default, the results contain all sales order fields. But see how they automatically use proper formatting for date and time fields, currency format for money fields, and even yes/no for Boolean fields. Right above the results grid, you can see a neat summary of the applied criteria. Next to the search and reset buttons is a link called Permalink, which puts the current criteria into the URL and allows you to bookmark it and thereby save your current search. The first column in the results grid has a link to the sales order details screen. So let's open it up for one of the sales orders and review its content. The details view again contains all sales order fields with editable controls, as well as two child grids for the detail and reason sub-objects, organized under separate tabs. Required fields are automatically highlighted with bold labels. At the bottom of the form, you will find buttons for standard actions to delete the sales order, save your changes, or just close the view without saving. As you can see, we have just built a pretty powerful set of screens for browsing and editing sales orders right out of the box. But the truth is, we haven't really done any modeling yet. All we've built so far is just a fancy database table editor. This is where a lot of tools stop. So let's model our application and tailor our screens to look and behave exactly how we want them to. We will begin with modeling our search view and specifically the results grid. Currently, it shows every single sales order field, including internal ones such as the row GUID. Our goal will be to show only a small subset of the most important fields that allows the user to browse sales orders without having to always open details of individual orders. So let's get rid of the revision number, purchase order and account number, addresses and credit card information, amounts except for the total, and the last three columns. In addition, we want the link to the details to be on the sales order number, which would go first, followed by the status. We also want to remove the time component from the dates, and instead of the customer ID, display the name of the customer store and/or person. While we're at it, I would also shorten the online order flag header to just online. So let's close our app and open up the XML model for the sales order. Our search screen is based on the sales order list view, which has sales order list data object as a view model. If we find all references to the sales order list data object, we will see that it's based on the output structure of the read list operation. The output parameters are added to this list object as data properties and represent the columns in our results grid. I'm going to remove the output parameters for the fields that we don't need and also move some parameters around to give them proper order. Next, I will set the type of the date parameters to be just date, as opposed to datetime that they inherited from the object fields. Finally, I'll change the customer ID parameter to a customer store with a generic string type, and we'll add a similar parameter for the customer name. To configure the look and feel of the result fields, we will need to go to the definition of this data object. The fields are configured under the UI display section, where you can hide fields, set the label to use, make them read-only, etc. For example, the CRUD generator was configured by default to make the internal sales order ID column hidden, since we don't want to show it to the user, but we still need it in the operations results to open the sales order details view. Let's go ahead and set the label for the online order flag field to a shorter text online. Built-in IntelliSense make it quite easy for us. In addition to the display section, data object has two links pre-configured, one to open the details and another one to create a new sales order. The details link uses our internal sales order ID and was configured to be displayed on the first column revision number. Now that we have removed that column, we're seeing a model validation error alerting us of that fact. Let's go ahead and change it to be on the sales order number field instead. With all these model updates done, let's build our model project again to rerun all the generators. We can run the application now, but there is a little problem. Customer store and customer name output parameters that we have added will always be blank. Their names don't match the names of any of the object's fields, and the system just doesn't know where to source them from. To rectify this, let's open the generated implementation class for the sales order service and navigate to the readList method. As you can see, for these parameters that the generator doesn't know how to set, it just inserted to-do comments, instructing you to populate them yourself. I will go ahead and set the customer store to the name of the store for the customer object. I will also set the customer name to the last name and first name of the customer's person object. You may be wondering now whether or not these changes will be preserved when the service implementations are regenerated. The good news is that normally they should be preserved as long as the text following the custom code start marker doesn't change. So for example, if you remove or rename these parameters or the operation, this custom code will also be removed. To avoid accidental loss of such custom code, we recommend that you store the generated code in a version control system where you can see the changes that were made after the code generation and revert any unwanted changes or restore the old code as needed. So now is the time to run the app and review our changes. As you see, the results grid contains only the columns that we want in the order that we specify them in our operation. The dates look great without the time component. Online column has our short header, and the customer stores and names are displayed perfectly fine. Also, the link to the order details view is now on the sales order number column. Now that we've got the first cut of our results list, let's see how we can improve our search criteria to make them less cluttered and yet provide all the needed functionality. This is where we need to think about the use cases for the screen and identify the corresponding criteria. Here are some sample use cases for searching sales orders. Looking up a specific sales order by a sales order number. Searching sales orders in a certain status. Finding orders placed during a certain time period. Finding orders that are past due or due soon. Finding large orders and small orders by the total amount. Finding orders by the customer store name or individual name. Searching orders within certain geographical regions and territories. Searching orders placed by specific salespeople. Let's go back to the read list operation in our model and take a look at the criteria input structure. By default, it's loaded with parameters for all sales order fields, including operators and a second parameter for the between operator where applicable. I'm going to remove any criteria that are not covered by our use cases and replace the customer ID criteria with separate search criteria by a customer store and customer name. Since their names match our output parameters, the system will be able to handle them and there is no need for any custom code for them. Notice also how I set the date type on the order date and due date criteria to get rid of the time component. Let's build our model project again to regenerate the code and then run the application to review our changes. Now the criteria panel looks much better, tailored to our specific use cases. The dates criteria have lost their time components, including in the criteria summary. Let's check how filtering by our new field customer store works. I will look for sales orders from the customer stores whose name contains the string sale. As you see, it works beautifully right out of the box. Now that our search screen has taken the desired shape, let's polish it some more and learn additional Zomiga concepts. If you look at the status field, you will notice that it shows internal, not user-friendly numeric values. For entering status values, it also offers a plain text field where you would enter the numeric value. However, the list of statuses is rather static, and each numeric value has a well-defined description. What we would like here is to select the statuses from that list and to display those descriptions instead of internal values. If we expand the status field on the sales order object, we will see that the status definitions are listed informally in the description of the field. Zomiga model allows you to formally define complex static enumerations, tie them to your model fields through dedicated logical types, and then use their cached data in the generated application. I will start by declaring a sales order status enumeration and listing all its items with both internal values and user-friendly names. Next, I will add a logical type with the same name and tie it to this enumeration. Given that the status field has a type tinyInt, I will make the new type extend tinyInt enumeration. This will make it keep the same physical types as the ones associated with the tinyInt, but it will also make it inherit selection UI controls that are associated with its ancestor type enumeration. The model is warning us that the new type is not being used, so I'll go ahead and set it on the status field. Let's build the model project again and run the application to review our changes. If I select status criteria now, the list of operators will be appropriate for enumeration, and the value can be selected from a drop-down list. The result list will also display a decoded value, and so will the criteria summary. While static enumerations can be described entirely in the Zomiga model, we may also want a similar behavior for dynamic enumerations, whose data comes from a database table rather than being defined statically, but is still static and small enough to be cached on the application side and selected from a list. Let's take a look at the salesperson and territory fields. They display internal IDs that are meaningless to the user and provide the same text box for entering them in the criteria. What we'd rather have displayed is the name of the salesperson or territory, and we'd also like to pick them from a selection list. Once we do that, we'll want to drop the ID part from their labels. We'll start with the sales territory. It has its own object in the model with a dedicated key type. Any field referencing a sales territory object will use this type, so we'll need to make sure that it will be configured for enumeration. Essentially, what we need to do here is to add a special read list operation, which would source the data for our enumeration and configure it as such. Zomega makes it extremely easy by providing a special model enhancement generator for it. As you see, it has added the read list operation, configured it with the named enumeration, picked which parameter will be the ID and which will be the description, associated this enumeration with our key type, and even changed its base type to be the integer enumeration. All I have to do here is to remove the unneeded output parameters to minimize the data in the cache. Let's move on to the salesperson object. Our key type salesperson has a base key type employee, which implicitly establishes a 0-to-1 relationship between the salesperson and the employee objects. So now we cannot change the base type here to inherit from an enumeration as before, so as not to break this relationship. Therefore, we'll need to use a slightly different approach. First, we'll turn off the configuration parameter of our model enhancement generator that updates our key type to make it enumerated. This is just one of the many other parameters that allows you to configure precisely how you want your model enhanced. Next, I will run the generator on the salesperson object. Notice that it added a read list operation and created a salesperson enumeration, but it didn't change our key type. I will need to change it manually to associate with the data property and web controls for enumeration types, which it would have otherwise inherited from its base type had we changed it to an enumeration type. I will also need to make it reference our newly added enumeration. The default output parameters of the generated read list operation don't have the salesperson's name to be displayed to the user, so I will add one and use a generic string type. I will also add a boolean parameter isCurrent, which would indicate if the salesperson is still with the company. This will allow displaying only the current salespersons in the selection list, but still be able to show the names for the salesperson IDs that are no longer working. Finally, I will remove the other parameters and will update the enumeration to use the new name and isCurrent parameters. Let's go ahead and build our model to regenerate all the code. Now we need to add custom code in the generated salesperson service class to implement these custom parameters. I will set the name to be the last name and the first name from the corresponding person object, and the current flag from the corresponding employee object. While we're at it, let's change the criteria by salesperson to allow multiple values so that we could search for orders by multiple salesperson at a time. This is as easy as just setting the list attribute to true on that criteria parameter. And now we're going to go to the definition of the sales order criteria data object and set the labels for the salesperson and the territory to drop the ID from them. Similarly, we will set it on the sales order list object for the column headers. Now let's build the model project one more time and run the app to review our changes. You can see right away that both the criteria fields and the result list columns use our proper labels. Let's pick a sales territory. As you can see, they are displayed in a nice drop-down list showing user-friendly names. Now let's pick several salespersons to filter by. Notice how the list of operators has changed for the multi-valued field and how it's using a list box as a selection control. Also see how the salesperson's name is displayed using our format with the last name and the first name. If I hit search, we'll see that the result list columns as well as the criteria summary use the same format. When you have a long list to select multiple values from, the default list box control may not work very well. Instead, you can let the users type in a list of internal codes or IDs in a text box, while also giving them auto-suggest list with matching values to select from. This would be similar to how IntelliSense works in our Visual Studio. We're going to see how easy it can be done for enumerated fields in Zomega, but more importantly, learn how to write custom logic for the presentation layer data objects. Imagine that the users are familiar with the numeric status values 1 through 6, and we just want to let them enter them in a text box with auto-suggest feature. All we need to do for that is to set a standard text box control on our enumerated status type. Notice that it will be used only for multi-values fields, and the standard dropdown will still be used for single selection. To turn this status criteria into a multi-valued field, we will set the list attribute to true on the status parameter, just like we did with the salesperson. Now the problem is that if we show the status text in the auto-suggest dropdown, but the user enters a numeric status value in the text box, that value will not match any item in the list. To make it work, the items in the auto-suggest dropdown need to display both the numeric value and the status text separated by a dash, for example. We will need to set this status display format in a custom subclass of the generated sales order criteria data object. If we set the customized attribute to true on our data object, the system will initially generate a custom subclass for this object, where you can put your custom code, and will also register that subclass with the dependency injection container. Let's build our model and go find the generated sales order criteria data object class. As you can see, the generated data object has its customized subclass nested under it. I will add one line to the uninitialized method where I set the display format on the status property to have both the ID and the text separated by a dash. Once generated, this class will not be updated by any subsequent runs of the model generators. This means that your custom code will be safe, but also that you have to manually clean it up should you remove that data object from the model. Now let's run the application and review our changes. You can see that our status criteria can accept multiple values now that are entered in a text box. The values can also be selected from the AutoSuggest drop-down list, which is filtered by your input for the current value and uses the specified format. Another neat example of custom code that we can put into our data object subclass would be implementation of cascading selection. When we select a salesperson, the list box will have salesperson from all sales territories. When we select the sales territory though, it would make sense to narrow down the list of salesperson to only that territory. This is trivial to do, given that the read list operation for salespersons that we've added before already has a territory as one of the output parameters. We just need to add custom code that calls a special Zomega framework function to set up cascading selection and pass it the name of the territory attribute on the salesperson. Notice how we can use a constant that was conveniently generated for us. With ASP.NET architecture, where the presentation logic is running on the server side, we also need to make sure that selecting a territory will make a post back to the server automatically. To indicate that, we can find the territory field on the sales order criteria object and set the isTrigger attribute to true. For this change, we can just regenerate the ASP.NET views instead of building the entire model project. So let's run the application and review the cascading selection changes. If I select the salespersons, it will show me the full list as before. But once I pick a sales territory, the list of salesperson will be filtered to that territory only, and its selection will be adjusted accordingly. The last example of custom code that I'd like to show you is on how to implement custom UI validations. We already saw that our system automatically validates required or invalid fields, but it doesn't know how to do cross-field validations. For example, if the user sets the from date later than the to date and tries to run a search, then we would like the system to display an error rather than always bringing back empty results. So I'll go back to our customized criteria object and will override the validation function to check the values for the from and to dates and report an error if both have values and the to date is before the from date. If we run our app now, open our bookmark, adjust the from date and hit search, we'll see our error displayed down below. Note that all our changes to the customized data object for custom validations, cascading selection, etc. are in the common client project and are not specific to the ASP.NET views only. So all this presentation logic can be reused with other types of clients, such as WPF. This is just an illustration of how Zomega framework helps you write reusable code. Okay, so we've modeled our search screen the way we'd like it to look, implemented static and dynamic enumerations, and also added some custom UI behavior. Let's switch gears now and model the sales order details screen. We'll use both the techniques that we've already learned and some new techniques that are more pertinent to details screen. Let's review what our details screen looks like right now. Speaking of reusability, you can notice that our enumerated fields already have drop-down list controls with proper values. We'll start with improving the detail child list, which shows the line items of the sales order. We're going to make the special offer and product display their names instead of internal IDs, set proper column labels, move the product column to be the first one and put the link on it, move the carrier tracking number to the end, remove the last two internal columns, and fix the formatting for the line total to use the currency format. I'm going to run the enumeration read list generator on the special offer object as we did before for dynamic enumerations. In the output of the generated read list operation, I could also add a custom isActive parameter based on the start and end date of the special offer, but I'll leave it for now and we'll just delete any extra parameters. I'll do the same thing for the product object. I'll remove any extraneous parameters except for those that we can use for cascading selection. The actual structure of the list of sales order line items is determined by the output of the read list operation on its detail subobject. I'm going to remove the internal fields that we don't need, rename product and special offer to drop the ID part, and place the remaining parameters into the desired order. To set proper labels for these parameters, I'll go to the associated sales order detail list data object and we'll set the field labels there just like we did before. Let's also change the link to the line item detail screen to be on the product column. Finally, let's set the money format on the line total field. The logical type it's using was added when we imported the model from the database and is used by only this field. So we can rename this type to something more appropriate, such as the same as the field name. Now we can go to the definition of this type and make it inherit from the money type to use the proper format. With model changes completed, let's go ahead and build the model project. If you remember, the product and special offer IDs in the child list were always shown as 0 because the system doesn't know where to read them from. We need to find the generated service method for this operation and provide custom code for these fields. Let's run the application, open up the sales order details screen, and review our changes. As you see, the line item grid looks now exactly how we wanted it. No extra fields, proper column order, labels, formatting, and display of the product and the special offer. If you look at the main details panel, you'll see that it has all sales order fields and all are editable. Some of them, such as the row GUID, are totally internal and should not be displayed at all. Others, such as the modified date, revision number, order date, and sales order number, can be displayed, but they are set internally by the system when the order is created or updated, so they should be read-only. Let's make these changes, and as we do it, we can also drop the time component from the order date and rearrange the fields to move the sales order number first and the revision number next to the modified date. The content of our sales order view is based on the structure of its view model, which is a data object called sales order object. If we check the references to this data object, we'll see which operations make up this object. As you see, it's mostly based on the input and output structures of our CRUD operations. The read operation goes first in the model, and its output contains all of the object's parameters, so it pretty much determines the order of the fields on the screen. To make our desired changes, I will move the sales order number up, set the date type without time on the order date, move the revision parameter next to the modified date, and remove the row GUID parameter. So far, so good. Now we need to make these parameters read-only. What exactly does it mean? Well, it means that such parameters should be read-only and not be updated. Duh. More specifically, they should not be present in any input structures, but only in the output structures as needed. So I'm going to go ahead and remove them from the input structure of the create operation and then add them to its output structure, since they are all set internally at create time and their new values must be read back. Notice also that I must use the same type for the order date to keep it consistent with the read operation. By the same token, we will remove them from the input of the update operation, which is nested in the substructure data. Update structure has no output, so we will add one and include only those parameters that are actually changed during the update. You also need to make sure to add these output parameters to our data object so that its properties are automatically updated with these values after this operation is called. These are all the model changes that we need for this, so I'll go ahead and build the model project. Now, sales order ID and number, as well as revision, are generated internally by the database when the order is created. The other parameters, including our internal row GUID, are not, and we need to set them manually in our service. For that, we will go to the create method of our generated sales order service and set these parameters in the custom code section. I also need to do the same for the modified date in the update method. Now, let's run the application and check out the changes that we've made. As you see, we no longer have the row GUID, and our read-only fields are displayed using labels rather than editable controls. They also appear in the right place, and the order date no longer has a time component, while, say, modified date still does, as it should. So far, the changes we've been making were pretty straightforward. Now let's model some more complex cases, shall we? For such a large object like ours, it's not a very user-friendly design to lump all its fields together on one panel. There are certain fields, such as those related to the payment for the sales order, that make sense to group on its own panel and place it in a separate payment tab next to the detail and reason. While we do that, we'll want to apply some additional fixes to these fields using the techniques that we've already learned. Specifically, we're going to drop the time component from the due date field, turn the shipping method into an enumeration with a drop-down selection, make all the amounts read-only since they are calculated by the system, and make the currency rate display read-only text instead of ID. I'm going to start with making a dynamic enumeration out of the shipment method. As usual, I'll run our generator on this object and remove any extra parameters. Next, we'll go back to the sales order file and declare a new presentation data object called sales order payment object for our payment fields. In order to display it with the other tabs, we'll add it as a child to the sales order object under the name payment. To add properties to our payment data object, I will add two structures in the model. Payment info, that represents the data that we can read from the services, and payment update, for the data that we can actually update. Both of them contribute their parameters to our payment data object. A few things to notice here. Firstly, the fields that appear only in the payment info structure but not in the payment update will be read-only. Secondly, the payment info structure goes first in the model, so the order of its parameters will drive the order of the fields on the screen. And lastly, parameters on these structures inherit their logical types from the corresponding fields on the sales order object. But we override the type on the due date to drop the time component and on the currency rate to display it as text. The model warns us that these structures are not being used in the model, so let's go ahead and update the object operations to use these structures. I will replace the payment parameters with the reference to our payment info structure, and will also move the ship date down for proper order. Next, I'll do a similar thing with the input structure of the create operation. This time though, I will replace it with the payment update structure. And finally, I'll repeat it for the input structure of the update operation. Now that the payment data object has properties, we can set the label for the shipment method field to drop the ID. Since our input and output structures are more complex now, the system doesn't necessarily know how to populate the payment info structure, for example. We will need to provide that custom code, but it will not be as small as the custom code we used before for individual fields, so we don't want it all mixed in with the generated code. This would be a great example of one of the ways how Zomega allows you to safely extend the generated service, write some complex custom code, and plug it into the generated service code. To make the system generate a separate file for the custom service code for us, similar to the customized data objects that we created earlier, we just need to add a customized element to the config section of the sales order object and set the extend attribute to true. Now let's build the model project and navigate to the generated extended service, which is conveniently nested right under the generated service. This is a partial class, so any functions we add here will be accessible and reusable in the generated service. But because it's in a separate file, we don't have to worry about generators overriding our custom code here. I'm gonna add a function that populates our payment infrastructure from a sales order object. Notice how I set the currency rate string using the properties of the corresponding currency rate object. Next, I will add a function that updates a sales order object from a payment update structure. It also checks the data provided and reports validation and data errors using Zomega framework. Now I can go to the generated read method and provide the custom code for the payment structure using our getPaymentInfo function. By the same token, I can go to the generated create method and call our function to update payment information. The beauty of this function is that I can also reuse it in the update method as well. That's pretty much all there is to it. We can go ahead and run our application, pull up the list of sales orders, and open up details of our order. The top main panel is much neater now with all the payment fields gone. And the payment tab has all our fields with read-only amounts, drop-down selection for the shipment method, due date without time, and the user-friendly text for the currency rate. Our next update will be similar to the previous one, but with a little twist to it. Let's take a look at the reason tab. It's modeled in the database as a child table of the sales order to allow specifying multiple sales reasons for a single order, and this design just got reflected on our screen by default. What we need instead is a multi-value field where you can select multiple sales reasons from the list of all possible reasons and use the name of the sales reason rather than ID. Instead of the reason tab, we'll want to put that field in a separate sales tab where we can also move the salesperson and sales territory to, fix their labels, and make the salesperson's cascade off the selected sales territory. We'll start by removing model elements related to the reason subobject that were added by our model enhancement generator by default. I will remove the CRUD operations on the reason subobject, the reason data objects, and the reason details view. To get rid of any previously generated artifacts for the removed elements, we need to run a rebuild command on the model project instead of the usual build command. Now let's turn the sales reason into a dynamic enumeration and remove any extra parameters. For selection of multiple sales reasons, I will use a pick list user control, which allows you to move items from the list of available reasons to the list of selected reasons. This particular user control comes with the Zomega template, but it's a good illustration of how to plug in your own custom controls. In order to add a child panel sales, I will first declare a new data object that will hold the sales reasons, as well as the sales territory and salesperson. We'll need to customize it to implement cascading selection, so I'll set the customize attribute. Then let's add it as a child to the sales order data object under the name sales. To add our properties to this data object, I will define a structure sales info. Notice that the sales reason is not a field on the sales order object, so it needs an explicit type. I also set the list attribute to true on it to indicate that it can hold multiple values. Since all these properties are editable, we can use the same structure for both reads and updates. So I'm going to add a reference to this structure in the read output and remove the other parameters. I will repeat the same for the input structures on the create and update operations. Finally, I'll fix the labels on our properties in the data object. Notice also how I set the isTrigger attribute on the territory field to enable auto post back for cascading selection. Let's build the model project again to regenerate all artifacts. Similar to what we did with the payment structure, we'll need to add custom code to handle the sales info structure as well. First, I'll add a function to populate sales info structure from a sales order object. To populate a list of sales reasons, we just use a simple select from a child reason list. Next, I will add a function to update sales info and sales reason for a sales order from this structure. To update the list of order sales reasons, we first remove reasons that are not in the provided list and then insert any missing reasons provided. And as before, I'll go to the read method and add custom code for the sales structure using our new function. Likewise, I will use the new function to update the sales info in both the create and update methods. The last thing to do here is to open the customized sales data object and add cascading selection code for the salesperson property. So let's go ahead and run our app to review our changes. I'm going to find our sales order in the list and open up its details. As you can see, instead of the old reason tab, we now have our fields in a new sales tab. The sales reason selection uses a pick list control which displays reason names rather than IDs. The territory and salesperson are also here, and the salesperson selection is filtered by the current territory. Our final set of updates on the sales order details screen will be for a more complex and yet the most important part of the sales order, the customer. Being able to view and edit customer details for a sales order is one of the primary requirements for this screen. Currently, the customer information is represented by just 3 editable IDs on the screen: the customer ID and the IDs of the bill to and ship to addresses. We will start by moving them into a separate customer tab, and instead of the customer ID, we'll display some more useful customer information, such as the store and/or person name, customer territory, and account number. While we're at it, let's also drop the time component from the ship date field. We'll do it using the techniques that you should be already comfortable with. First, we'll declare a customer data object and add it as a child to the sales order data object. Next, we'll define 2 structures for this data object: customer info for reading customer information, and customer update for the customer fields that we can update on the sales order. While we do want to read the internal IDs for the customer, store, and person, we don't want to display them on the screen. So I will go to the data object and will set these fields as hidden. I also set the label for the territory to drop the ID part. Now I'll replace these parameters with references to our structures in the read, create, and update operations. I'm also going to change the type of the ship date parameter to use just the date. Let's build our model to regenerate the code and go to the extended sales order service class. I'll add a function to get customer info from a sales order. As you can see, I retrieve new parameters from the related customer object and use both the first name and the last name for the person name. Similarly, I'm going to add an update customer function which does all the validations and null checks. And finally, I'll add custom code to call these functions in the read, create, and update methods of the generated sales order service class. If we run our app now and open up a sales order details, we'll see that the customer fields are now in its own customer tab, showing customer information rather than ID. This is close to how we wanted, but there is a little problem here. How do you select a customer for a sales order now? To allow selecting a customer, we're going to have to use a totally new technique here. Keep in mind that there are thousands of customers in the system, and we simply cannot let the user just pick it from a drop-down list like we do with the salesperson. What we need to do is to build a customer lookup view that would be invoked from the sales order details screen. It would allow searching for customers by certain attributes and then selecting a specific customer, which would then populate the customer information on that sales order. This may sound quite complicated to you, but luckily, Xomiga makes it just a walk in the park. First, we need to add a read list operation and a search view to the customer object. We can use our model enhancement generator for that, but because we don't need the CRUD operations nor the details view, I'm going to copy it as a new configuration, give it a name lookup view, and turn off generation of the CRUD operations. So let's go ahead and run it now on the customer object. The output parameters of the customer read list operation at a minimum should have all customer attributes that we display on the sales order so that we could populate them when we select a customer without having to make an additional call. We may also show other columns in the customer lookup view to help the user select the right customer, but I'll just use the same set as we show on the sales order for now. As far as customer criteria go, I'll just let the user search customers by the same fields as they see in the view. To add implementation for our custom store name and person name parameters, I'm going to build the model project and then go to the generated customer service class and add custom code in there. Now we need to just go back to our child customer data object and add a link to the new customer list view. We call it lookup, and we pass certain parameters to the target view to make it allow single selection. We also need to provide a section that tells the model how to handle the selection results, that is, which output parameter goes to which data object field. Let's build the model and run the app to take a quick look at what we've got so far. As you can see, we have a lookup link button in the customer panel now. If I click on the lookup button, our customer list view will pop up. Let's say I'm looking for a customer with a person named Mike. As I hit search, I get a smaller list of matching customers to select from. I'm going to select Mike Hines from the first cycle store and hit the select button to confirm. Lo and behold, our customer was successfully updated on the sales order. Now the users have a flexible way to search and select customers. Flexible, but not that convenient. Imagine trying to enter multiple sales order fast when you already know the customer's person name or a store name. Having to always enter it in a search screen, especially if you will only get one customer, would be rather tedious. A better design would be to give users a sub-panel here, where they can enter part of the name for a person or a store and hit lookup. If that name matches only one customer, it will be auto-populated on the sales order. Otherwise, the customer lookup screen will pop up showing the matching customers. Without further ado, let's go ahead and update our design accordingly. First, we'll add a new lookup data object and move the lookup link to that object. Model validation will tell you immediately that the fields from the link are not on that object, but we'll fix it momentarily. Next, let's add this object as a child to the customer data object. Now we can indicate that these fields come from the parent object, which fixes these validation errors. We will let the users enter part of the store name or a person name there. So in order to add these properties to our lookup data object, I'm going to define a new structure with these parameters. We're not going to use it in any of the operations, so it's marked as generic. Finally, we need to set up the link parameters so that the values for the store name and person name criteria come from the respective fields and the operators use a fixed value contains. That's all there is to it. Let's build our model and run the application to review our changes. As expected, there is now a lookup subpanel with our two fields and the lookup button. If I enter the person name Hines and hit lookup, the customer will be auto-selected, since that's the only one matching this name. On the other hand, if I enter Mike and hit lookup, I will see the customer lookup screen with all the Mikes to select from. You can see that the person name criteria were automatically pre-populated and applied. Now I can select a different Mike and it will just work as before. The last thing to address on the Customer tab would be the Build to address and the Ship to address. Those are IDs of normalized address records that are associated with the current customer's store or person. Instead of entering the actual IDs, we want to select them from a drop-down list that shows user-friendly text for addresses specific to the current customer only. If the customer changes, the list should also change and their values should be reset. The list of addresses for a store or a person is tracked by the Business Entity Address object. We'll use a technique similar to dynamic enumerations. But the full list of addresses for all customers is just too large to be read all at once and cached in the presentation layer. So I'm going to add a read list operation that takes a business entity ID as an input parameter and returns a list of address IDs and address types for the given entity, which will be used as a key and description respectively. This enumeration will allow us to generate a cache loader class that we can use. Next, I'll go to the address logical type and make it inherit from the integer enumeration to use a drop-down list for the selection. I don't need to associate it with our business entity address enumeration in this case, since we will be manually populating the list. To add custom code for reading customer addresses, we will need to customize the sales order customer object. Let's build the model and go to the generated customized object. Here, I'm going to add a small address loader class, which inherits from the generated cache loader class for our enumeration, takes the customer data object, and subscribes to the changes of the store or the person IDs. When any of those change, it calls the base method load cache and sets the resulting list of addresses on the build to and ship to properties. To ensure that the base load cache method makes a proper service call, we override the generated read list method and pass the business entity ID of the customer's store or person. Now, to hook up this class, we just need to construct it in the initialize method of the customer data object. Finally, we need to go to the generated business entity address service and provide custom code in the read list method. We'll set the output address ID and address type, but more importantly, we need to fix the source filter to use the specified business entity ID. If we fail to do that, it will return thousands of rows for the drop-down list, which will quickly bring the UI down to its knees. Let's run the app and take a look at our changes. As expected, instead of address IDs, our fields now show drop-down selection with address types for the current customer. What's lacking here is ability to see the details of each address. To display such details, we want to move each address into its own subpanel, similar to the lookup panel here. Let's close the app and take a look at the address object. We pretty much want to display the typical address fields. As you see, they use some odd types that were generated during the model import. To make the model easier to work with, I'm going to define more meaningful logical types and refactor address fields to use those. Next, I'll go back to our business entity address enumeration and we'll add the extra address parameters that we want to return in addition to the address ID and type. We can also rename the string 50 type, which is mostly used by name fields, so we'll call it name. Going back to the address file, let's declare the address data object for our panel. I will need to customize it to implement updating of the extra address fields when the address changes. To add properties to the data object, I'm going to add two structures here. One for just the address key that we'll use in our operations, and a generic structure for the extra address info. With these fields added to the data object, I can now configure their display. Since the address info structure will not be part of any operations, I have to manually set all the extra fields as not editable. Also use proper labels and set the isTrigger flag on the address ID field so that the other fields could be refreshed after the address is changed. Now we just need to make a couple of final model updates to add the billing and shipping addresses as child objects of the customer data object, and update the customer structures to use our address key structure instead of address IDs. Now let's build the model project one more time so that we could finish with adding our custom code. First, we'll go to the readList method on the business entity address service and provide custom code for all the extra output parameters, pulling their values from the associated address object. Next, we'll need to refactor our custom code in the sales order service class for both get customer info and update customer functions to use the address key structures. By the same token, we'll refactor the address loader in our customized data object to use the child address object. And finally, we're going to go to our customized address data object and add a listener for the address ID property, which would populate our additional address properties from all those extra enumeration attributes that were returned in the read list operation for the business entity addresses. It may have been a little too much to digest, but let's run our application again and see the results of our hard work. What we see is a beautiful customer panel now, with billing and shipping addresses in separate subpanels showing the information we need. Let me select a different customer, and voila, the address fields get all blanked out and you are required to select the address types now. Once you select them from the drop-down list, the address details get populated in the panel. This is a large and complicated detail screen, and there are more functional updates that we can make to it, but what we've done so far is already very impressive. It demonstrated the power of model-driven development coupled with code generation and the flexibility unleashed by the custom code. Speaking of flexibility, let's talk about layout of the views and the ways we can control it in our model. By default, fields on the panels are laid out in two columns, flowing vertically down the columns. We can change the number of columns and make the fields flow horizontally across the columns. We can also set a fixed size for the view, but more interestingly, we can change the layout of the list screen to open the details view as a separate panel in a master details fashion, as opposed to a model pop-up view. Let's take a look at how to do it in the model. Inside the view definition, you can add a UI layout element and pick one of the saved layout to be used as a base. If we go to the definition of the standard layout, which is the default, we'll see that it uses the pop-up details mode, two columns for criteria and details panel, and arranges child panels as tabs. Back in the layout for our view, we can override any of these base settings. Let's set the size of the view to 840 by 640 pixels. To change the layout of the list screen to master details, I will pick it as a base layout. If you ever need to manually change the layout of the generated view, you have an option to set the custom attribute here, and that will prevent the view from being regenerated to preserve your manual changes. The obvious downside of this is that your view will no longer be automatically updated when the model changes, and you will have to make all the updates manually. So let's build the model and run the application to review our layout changes. If we pull up our sales order list screen and hit search, it will look almost exactly as before. But let's click on the details link and ta-da! Our details view opens in the side panel, and you can switch between different sales orders or just close that panel. The last topic that we want to cover in this video is related to something that virtually any application needs: security. We want to allow access to the application only for authenticated users and then restrict access to systems functionality and data based on the user's roles and privileges. There is no user object defined in our sample database, so we'll use the person object as the surrogate for the user. The person object doesn't have a unique user-friendly ID, so we can use the person's email address and their hashed password to authenticate the user. There is also no explicit object for user roles or privileges, so we'll use the person's type to determine their role. Some of these roles are for external users, which are associated with either a customer or a vendor. We want to make sure that such users can see only sales orders related to their customer or vendor. To implement all this, we're going to use OWIN authentication coupled with the standard claims-based security framework. So let's update our model to allow us to construct the claims identity for a user. First off, let's formally define a person type enumeration in the model from the description of the field. Next, let's define a logical type email for the user ID. We can also pre-configure a text box control for it. Now I'm going to add a person info structure that contains all required security information about a user. And then I will manually add a read operation, which takes an email address as an input, looks up the person by that email address, and then returns the person info structure. Given the non-standard input and output structures, the generated implementation for this operation will be totally no good, so it's better to just subclass the generated service and provide our custom implementation. To create such a subclass, I'm going to add a customized element to the object's config section like we did with the sales order, but this time I will set the subclass attribute rather than extend. So let's build the model and take a look at the generated person service. As you see, the generated read method is pretty much useless, but we can override it in the customized person service subclass, which is nested right under the generated service. I'm going to add an override implementation which uses a more complicated link query to look up the person info by the specified email and report an error if it wasn't found. In order to actually construct a claims identity from the person's info, I'm going to add a common utility class called Security Manager. In there, I'll have a static method createIdentity, which takes authentication type on the person info structure and constructs a claims identity for the given authentication type. It adds some standard claims for the user info where the person type serves as a user role. It also adds custom claims for the customer store and vendor IDs using special declared claim types. Now that we've got all the ducks in a row for the claims identity, let's model and implement a login view and the underlying authenticate operation. First, I'm going to declare an authentication data object, which will be a view model for our login screen. Next, I'll add a credential structure, which will have the email and password parameters that will be added to our data object. Then I will add an operation called authenticate, which will accept credentials as the input structure and throws an error if the credentials are invalid. Even though it's not going to update anything, I marked it as update type so that the login view could be generated with a wired up save button for it. Finally, let's add a login view based on our data object. Here's an example of where we override the standard layout to stack the fields in one column and set the view size. We set the child attribute so that it doesn't get added to the main menu, but more importantly, we need to set the customize attribute in order to implement OWIN cookie-based authentication. This is specific to the ASP.NET architecture, so we need to customize it on the view level as opposed to the data object level like we were doing before. Let's build the model to get all the artifacts generated. We need to provide implementation for the authenticate service method, which I'll also add to our customized subclass, since the generate method for it is just as empty. Here, I need to look up the stored hash password by the provided email address and then hash the provided password using stored salt and compare the two. but for the testing purposes, I'll just compare the provided password with the word password. Now let's go to the web project and open our customized login view, which is nested under the generated login view and subclasses it. This is where you can programmatically customize the view's appearance and behavior. So I'm gonna set the text for the save button to be login and adjust the width of the main panel. We will also handle the case when an already authenticated user was redirected to the screen if they were not authorized to access the view they were trying to open. The Save Login button will automatically validate the user input, call our authenticate operation, and display any errors as a result. All we need to do to implement OWIN claims-based authentication is to implement a view event handler for a successful save/authentication. Here, we call our read operation with the user's email address and construct a claims identity using our utility method. If everything is good, we sign in with OWIN using our constructed claims identity and redirect to the view that was originally requested. To actually secure our web pages for authenticated users only, I'm going to open the web config under the views folder, and instead of allowing all users, I will deny anonymous users access to any page except for the login view. The last thing we need to do for authentication is to configure the path to our login view. We can either change it right here in the OWIN startup class or change it in the root web config on the URL rewrite rules. Now let's run the application to review our changes. As you see, we are redirected to our login view, which makes you supply email and password as credentials. If I enter invalid credentials, it will actually call our authenticate operation and show the error that it returns. Once I enter a valid email address and password, the system logs me in and displays my name in the top right corner of the screen. I used an email address for an external user that is associated with the customer. Even though the system now requires authentication, it still displays all sales orders, including those for other customers that I'm not supposed to see. Following security best practices, let me show you how to update the service layer to secure the sales order data. First off, let's open our utility class Security Manager and add to it several convenient extension methods for iPrinciple interface. These include determining the user's role, whether it's a store contact, an individual customer, or an internal employee or a salesperson, as well as retrieving the store ID or person ID associated with the user. Notice how we use the constants generated for our person type enumeration. Next, let's open up our generated sales order service. To allow viewing the list of sales orders only to internal users and customers, but not vendors, for example, I will add a custom code at the top of the read list method, which reports an error if the user is not in one of these roles. This is where I use our extension methods on the current principle. Now, to ensure that customer users can view only their own sales orders, I'm going to add custom code under the source filter section, which adds a filter by user's store ID or person ID to any query as appropriate. To review our changes, let's run our application and log in under the same external user J. Adams. If I open a blank sales order list screen and hit search without specifying any criteria, I'm going to see only my sales orders now, which is exactly what we want. While you should always implement full security on the service layer, it's often desired to add security on the presentation layer as well. For example, now that we display only their own sales orders for external users, it doesn't make sense to show them criteria by customer store or person. We'll do it in our customized sales order criteria data object. I'm going to add code that sets the access level on the customer store and name operator properties to none for external customer users, and the Zomega framework will take care of hiding the fields bound to these properties as well as their associated labels in this case. Remember that all this code is not specific to ASP.NET and can be reused with other types of clients such as WPF. So let's run the application, log in as our customer user, and open up the sales order list screen. You can see that the customer criteria are hidden now. Let me log out and log back in as a vendor user. Customer criteria are back, but the vendor user is not even supposed to have access to this screen. If I hit search, I'll see our security error from the service, which means that the service is already secured. To restrict access to the sales screens only to internal users and customer users, we can use the standard ASP.NET authorization configuration in the web config under the views folder. Now, if I run the application and log in as a vendor user, you can see that the menu options under the sales menu are all missing. If I try to open our bookmark, which uses the direct URL, we'll see the unauthorized message that we put into our login view. This is pretty much all I wanted to show you in this video. I would like to thank you for bearing with me for this long, but look how much we've done in just under 1 hour. We have basically built a secure, multi-tier web application with a complex, fully functional sales module for browsing and entering sales orders. Imagine how much time it would take you if you had to build it from scratch using traditional tools. And now, imagine that you have to build out other modules of the system as well, such as for human resources, production, purchasing, etc., and what kind of savings you would get with Zomiga in this case. Large-scale projects is where you can reap the most benefits from the model-driven development. And all the different ways to easily customize both behavior and look and feel, from updating the website templates, CSS and model configurations, to writing complex custom code, will help you tailor each application specifically to your needs and not just build cookie-cutter solutions. Before we wrap up, let me quickly mention the Zomiga extensibility that is available with the full Zomiga license and allows you to truly unlock the full power of the Zomiga platform. You will be able to update or extend existing Zomiga generators. For example, if you want to change the layout of the generated screens beyond what can be configured in the model. Or if you need generated code to use certain frameworks such as logging or to adhere to certain coding standards. You can also extend the model structure, such as by adding custom attributes or even whole elements that you can then leverage in the custom generators. You can then implement the same features for your custom elements that are available for the standard model elements, such as model validation, IntelliSense support, collapsing to definitions, finding references, refactoring, and so on. And finally, you'll be able to create and run your own XSLT-based generators. Those may be needed to support different technologies, such as mobile or cloud applications, or different frameworks, such as third-party UI frameworks. You can also build them to generate a completely different type of artifacts from the model, such as mock classes or unit tests. So where do we go from here? If you're looking to build a desktop client instead of or in addition to the web client, please watch our video on how to build a WPF application on top of the model we've created in this video, where you can reuse the service layer and even a large piece of the presentation layer. If you prefer a more modern HTML5 single-page application instead of the traditional ASP.NET Web Forms, then go ahead and watch our follow-up SPA video, where we expose the service layer via REST and add a TypeScript-based HTML client to it. Would you like to generate comprehensive, detailed design documentation for the domain and service models directly from your Zomiga model? Check out the video where we show you how to do it. So go ahead and download Zomiga and order a license on our website to get started with model-driven development today. We love your feedback, so don't hesitate to contact us with any questions or issues. I hope you enjoyed this video, and I'm looking forward to hearing from you soon.